Hi, hello, my dear friends. Welcome back to the channel. This is the new series related to multi-UV in 4G or 5G OFDM system. So, in this series, I will talk about various multi-UV concepts. Please stay tuned. In this particular video, I will be talking about the concepts related to how multi-UVs are scheduled, the concept of multiplexing and multiple access, and the difference between them, and also the difference between OFDM and the OFDMA. To understand how multiple UVs are scheduled, uh, we need to first get the concept of OFDM grid. So this is the OFDM grid which I have represented here. This is also known as resource grid. Okay. So as per the GPP spec, this one particular column is called as one OFDM symbol, and the y-axis represents the number of subcarriers, and the x-axis represents number of OFDM symbol. So number of subcarriers will be corresponding to the bandwidth chosen. Here, for the sake of simplicity, I have taken only 24 subcarriers. Okay. So this particular grid consisting of 14 symbols and the number of subcarriers corresponding to the bandwidth. This is nothing but one slot. Okay. So the concept of OFDM grid or resource grid has been explained in my previous videos, so please go through them. I will give the link in the description box as well. The concept of one slot is very much important because whether it is the transmit processing or receive processing, uh, it is done on a slot by slot basis. Okay, for a particular slot, the resources are static, whereas in the next slot, dynamically the resources will change. So that's why slot concept is important here. Um, so I will consider the example, the base station and the UV. Okay, so let's say the signal is flowing from base station to UV. So in this case, how the resources can be allocated, and let's say there is only one UV. So since we have 14 symbols, we can allocate all 14 symbols to the single UV, and even we can allocate all the subcarriers to that particular UV. Okay. Now this has happened for one slot. What about in the next slot? Next slot also, since there is only one UV in the system, if the UV has some data to be downloaded, you can allocate the resources in the next slot as well, and it can be allocated all the slots. Now let us consider uh, the multi-UV. Just I will take two UVs in the system, okay, to understand the concept better. Now, how can these two UVs be scheduled? One way is, for a particular slot, okay, for one UV, you allocate all the resources, whereas in the next slot, you allocate all the resources to UV number 2. Okay, in this case, the concept is called as in this case, what can we say is, there are multiple UVs in the system, but only one UV per slot is scheduled. All right, but what is the problem here? The problem is that for the second UV there is a lag. Okay, you might see buffering happening in his video. It is not served immediately, so we should be serving the users as much early as possible. Okay, so um, the concept is, we would be having so much subcarriers, right? So you divide some subcarriers, okay, up to this much for UV number 1, and for few subcarriers you divide to UV number 2. Okay, but in the frequency domain you allocate all the 14 symbols. Okay, that's how that is usually followed in the system. So all 14 symbols are allocated to UV number 1 as well as UV number 2, whereas um, you know the resources are divided in the frequency domain by allocating the different set of subcarriers. So in this case, since two UVs are allocated per slot, it can be written as 2 UVs per slot, and in the subsequent slot also you can follow the similar strategy. Maybe depending upon channel conditions, the resource allocation done for UV number 2 might change. Maybe this much can be allocated to UV number 1, and this much can be allocated to UV number 2. Of course, I have just mentioning this, but this is for the entire the symbols. I hope the multi-UV concept you got it, how the resources can be divided like that. In the system there can be 16 UVs per slot. Okay, in which case all these subcarriers are divided to different UVs. Now, what is this concept called as multiplexing and multiple access? So the definition is that you take two signal S1 and S2, and if you're adding these two signals and you're transmitting, okay, you're transmitting, and it is intended to only one receiver, one RX, then here we call it as just multiplexing. Okay, so this is what we are doing. Like this S1 and S2 are nothing but subcarrier 1 and subcarrier 2. You are multiplexing, and then you're transmitting such that it is intended to only one receiver. But what if I say S1 is there, S1 S2 is there, but this is um, these two I am actually multiplexing. Okay, plus, but the thing is that S1 is intended for UV number 1 and S2 is intended for UV number 2. In such case, this is called as uh, you know mm, it is called as multiple access. In case of OFDM, okay, so we are dividing the resources in frequency domain. Orthogonal subcarriers S1, S2 up to Sn are added together, and we added together, it is like multiplexing, and it is intended for only one receiver. Okay, in this case, but the moment we say OFDMA, in this case, out of these n out of these n subcarriers, few subcarriers are intended for one particular RX, and few more are intended for another receiver. So there is a multiple access happening, and multiple access happening based on the resource division in the frequency domain, and these resources are orthogonal, and hence orthogonal frequency division multiple access is referred in case of 4G or 5G when um, the signal transmitted from the base station is intended for multiple UVs as shown in this figure. I hope the concept of OFDM and OFDMA is clear, and also from this the multiplexing and multiple access concept is clear. Thank you very much. In the upcoming videos, we will see more concepts related to multi UV. Thank you very much. Please do subscribe for more videos.